Hi everyone and welcome back to the channel. Today we will solve the leetcode problem, determine whether matrix can be obtained by rotation. So we are given n by n binary matrices, mat and target, and we need to return true if it is possible to make mat equal to target by rotating mat in 90 degrees increments or false otherwise. So let's break this down in the smartest way possible. We are given two square matrices, mat and target, and our task is simple. Can we rotate mat by 90 degrees multiple times to make it exactly equal to target? So now instead of guessing, we will try all possibilities. So we need to try the rotation by 0 degree, 90 degree, 180 degree, and 270 degrees. These are all the possible rotations. And here is the key trick. When we rotate a matrix 90 degrees clockwise, each element moves using this formula. The row becomes column and the column becomes reversed row. So that means that mat of I and J will equal the rotated matrix, rotated mat of, as I said, the row will be column, so the I will be J, and the column J will be reversed row. To calculate the reversed row, it will equal the size of the matrix minus 1 and minus I. Why minus I? Because as we go through the mat from up to down, we have to go through the rotated mat from down to up. This is why we subtract I. So let's assume if we have 3 by 3 matrix, then if we take position 0 and 0, then we'll map to position 0 and 2. Why? 0, the row becomes the column 0 and the column becomes the rotated reversed row. If n equal 3, so 3 minus 1 minus 0, that will give us 2. And again, if we go to position, let's say 1 and 0, again, if we use our formula, that will map to position 0 and 1. So if we apply this to all the elements, everything shifted in circular rotation. So what do we do? Let's move to the code to see the implementation. First, we will define the size of the matrix as it is a square matrix. So we only need one variable. Let's call it n. After that, we will loop 4 times because we need 4 rotation here. So for n k equals 0 and k is less than 4 and plus plus k. First, we will check if our mat equal the target. In this case, we return true immediately. Otherwise, we rotate the matrix. We can do this in place, but for readability and explaining this video, I'll define a new extra space. So I'll define a new matrix. Let's call it rotated. So vector of vector of integer. Let's name it rotated, and it's gonna be of size n, size n of n, and then we will loop from I to n equal 0 to I less than n plus I, and we will loop on the columns j equal 0, j is less than also n, and plus j. In this case, our rotated matrix of j and n minus 1 minus I will equal our math of I and j, and after this loop we will assign math again to rotated. Why? Because we need to, here we check if the math is equal to the target, and to use math again for the rotation. Otherwise, at the end we need to return false. So let's run it, and let's submit it. Well, as you can see, it beats 100% of the performance. And in terms of complexity, each rotation takes O of n squared, and we do it 4 times. So the total is O of n squared. This is efficient and clean for this brute force solutions. And that's all for today's solution. If you enjoyed it, please like and subscribe for more videos like this, and follow Let's Program with Hussein. Thanks for watching, and happy coding, and see you in next video.